Thank you very much. As Andre said, my name's Abby Sassel. I have been working as a Haskell developer now for about a year and a half, or since May of last year. And as you may have seen on the program, I'm here to give you an experience report into a year's, roughly the first year or the first few months worth of learning and working professionally with Haskell. Or more specifically, a brutally honest experience report of learning and working with Haskell. So I wish all of you, first of all, the confidence of me from 4 months ago who wrote this talk, when I wrote this talk abstract, who had no idea what I was going to be talking about, but I did know that it was going to be brutally honest. So this will be essentially a talk on my experience learning Haskell, the things that I've discovered, resources for those of you that are new. If you are relatively new to Haskell and maybe been working with it for a year or under, if you could just raise your hand so I get an understanding of the newbies. Cool, okay. So it will be, so for the newcomers to Haskell, it will be more of a, this has been my experience, this has been my, these are my suggestions for resources to have a look at, things to try, things to avoid. I think that's super important because I don't know if any of you, whoever's on Twitter might well have already seen this idea of the Haskell pyramid that I think Julie Moronuki has tweeted about a couple of times. But it's the idea that in this whole kind of space of learning Haskell, all of the potential concepts and things that you can learn about Haskell, actually what you need to know to be productive and to enjoy working with Haskell is relatively low down this, I mean, it's not even this triangle. So the base of this pyramid are the things I think that you need to sort of be able to understand and pick up in order to have fun with Haskell and do your own small projects and maybe even work professionally with Haskell. However, what gets discussed on social networks is the things that are in the absolute boundary of what we can do with the Haskell as a language and the compiler and everything else, which I think is fantastic, but at the same time can be quite very intimidating to newcomers, and I think it's worth talking about a beginner's experience to give those of you who are new an understanding of where you can get to in the next sort of few months. For those of you that are long-term Haskell practitioners, which I'm assuming for probably a lot of you is that anyone who didn't put their hands up, I'm hoping this talk will be an overview of a few of my observations about the Haskell ecosystem and community and some of the things that I've come up against as a newcomer, and maybe even some suggestions about how I think we can possibly improve the community and improve the ecosystem and make it even better for newcomers to Haskell in future. So I think that comes from as well, one thing that I should mention is that I do have a little bit of experience in developing, I suppose more, I'm not an academic, but I have a bit of experience developing informal learning communities. So I work a lot with Closure Bridge London, which is an open and free workshop for underrepresented groups trying to learn dynamically typed functional programming languages like Closure. So I'm super excited to sort of give an idea of I think how we can make Haskell the best, I suppose, community for learning that it can be. It's a fantastic language and we all want to be working with it, so let's try and make it as open as possible.
I find it amazing that you seem to imply that everything that gets discussed on social networks is part of the productive Haskell.
Yeah, this triangle's slightly flawed. Maybe it should have been like a Venn diagram or something. I don't know. This is a very good point.
Add a second red line.
Yeah, maybe let's just slice a little bit off, and then like this, the bottom of this bar, I don't know why I'm walking over there, so the bottom of here is just the hours that you spend going down rabbit holes and not doing anything particularly productive, and just doing loads of reading, and then all of this is just Twitter feuds, and things like that. So overall, I think the last kind of motivation thing that I'll say on this bit is that as Haskell practitioners, obviously, we're all here because we all really enjoy working with Haskell. I feel like we should spread the good word of Haskell and be evangelists for just how much fun it is to work with. I think when I talk about making communities more, I suppose, inclusive or reducing barriers to entries, which I will be doing as part of this talk, a few people get nervous and sort of, the first thought that comes to mind, or the first question that comes to mind is, oh, what if we reduce the overall quality of the community or the output that people are, contributing in open source and things like that. And I suppose the first thing that I would say after I've stopped grimacing is that I think as a community, Haskell's always going to be, Haskell has a reputation for being hard to learn. And I think that reputation has perhaps some merits in that I think as software engineers, when we're first coming to learn Haskell, maybe from other languages, there are lots of things that we have to unlearn and in order to, I suppose, get into the Haskell mindset. And I think when we talk about Haskell being hard to learn, that side of it isn't going to change. I think it changes how we think as maybe some of us academics, some of us software engineers, but overall programmers. And I think that is a good thing. The thing that I think contributes to that whole idea of Haskell being difficult to learn that we ought to change is access to the ecosystem, access to documentation, access to the things around the core Haskell language that don't need to be as hard as they are. And I think overall, by improving that and by making that more accessible, we can improve the quality of the community and the accessibility of Haskell and overall the output, so that everyone can do better work. So my getting started journey, in the sort of the description of this talk, I mentioned the kind of Haskell the hard way. The reason I call this Haskell the hard way is because I essentially got someone in this room contacted me about a Haskell job opportunity at a very large international bank that I think has possibly about 3 million lines of code, Haskell code. And this person was an ex-colleague of mine, and it was working with a small, super clever team on a really exciting project to develop, I suppose, operations and tools for a team of quantitative developers. And it was all in Haskell and PureScript, and I thought, fantastic, this is an amazing opportunity. I don't know any Haskell, but the worst thing that can happen here is that I'm part of an incredible team. It's a sort of, I suppose, a sink or swim environment, and I can learn Haskell in the run-up, and then apply it on the day-to-day in my daily role, and then if nothing else, learn from the fantastic people that I'm surrounded by and make the most of that opportunity and being part of that overall project. So having had that discussion, having accepted the job role, this was about April of last year, I was like, okay, fantastic. Now I need to start learning Haskell. So the way that I did that, I compiled I have to plan everything. I can't just sit down and figure stuff out and learn Haskell. I had to kind of check all of the how to learn Haskell Google results and things like that. So I've compiled a small list of kind of, I suppose, meta resources or things that are things that I think would be super useful to people at every level to learn Haskell. After figuring out what resources to go at first, understanding, kind of limiting myself to a short space of time where I studied the syntax and a few core concepts. So core data structures and how to compile small programs and compose functions and things like that. After a short space of time, work on exercises and progressively larger and larger Haskell projects, or more and more complicated Haskell projects, and then repeat and iterate over that and learn more concepts the next time round, or go over things that I didn't understand the first few times. What I will say about that in terms of advice for possible beginners is that I've done this and I've limited this to a short space of time, primarily because I know that I read as a procrastination technique, and I just don't do I don't do the thing. So I think the first book I looked at was the Haskell from First Principles book, which is fantastic, and which is the first, I think, on that list of resources. And it's very easy for me just to read through the first 3 or 4 chapters and be like, yeah, I get this. Yeah, this is fab. And then not do the exercises and not have any of that validation that I'm actually learning the thing. So I wanted to get quickly into coding. I had some fantastic advice from the people that I would be working with at this large international bank, was develop a small application using the tools that we would be using on this project. So in particular, that was Servant. It was a small library called Servant that was for sort of a typed API, generating some types in Haskell, creating some types in Haskell, and then using something like PureScript Bridge to convert Haskell types to pure script types, and then surface that in a small kind of web application. And the idea being that by using these tools and I suppose achieving this thing, I would have proven that I've kind of solidified my knowledge at the level that I needed to start this role. So I would say that this was a great piece of advice. This is a fantastic piece of advice. Thank you, David and Ben. Features of good advice. The reason this is good advice, I think, is first of all, it's goal related. So I want to learn Haskell. How can I do that? How can I prove to myself that I've achieved this, gone past this learning step? It's goal related. I don't want to mention the cringy kind of marketing-y or management-y like SMART goals, but essentially this advice is great because it's specific and it's measurable and it's achievable. I know once I've completed this because I have a finished application, and I can do that within a fixed period of time, and I can measure the things that I've learnt. And it's based on the giver's experience, so it's coming from a sort of, I suppose, a qualified and experienced background. At the same time, I got some more advice. Unprompted from another well-meaning Haskeller in the community that I think this was on my first or second time of meeting them. And I said, I'm here and I'm really keen to learn Haskell. I'm going to be working at this place soon and I'm super excited. And they were like, great, don't learn Haskell, learn category theory. But not category theory for programmers because it's not academically rigorous enough. And I was like, well, what is category theory? What does that have to do with learning Haskell? And so I would say that I point this out as, by the way, this category theory for programmers is absolutely fantastic, and at some point, if you are interested in learning category theory, I do not agree with any of this statement, so put that aside. I would say that this is bad advice because it is precisely the opposite of the advice that I had before. It's not particularly specific, unless you're talking about specificity, like what I shouldn't be doing, which isn't helpful. It's like you're taking, a slice out of a pie of all the possible things that the amazing things that I could be doing to learn Haskell, and you're telling me what not to do. That's not particularly helpful in kind of, I suppose, guiding me towards a productive learning experience. And then I think this whole kind of statement around don't do this thing because it's bad, and not for any sort of, there are no reasons behind this statement. There was no examination of, oh, well, you could consider this resource or this resource. It was very much a statement of don't do category theory for programmers because it's bad and it's not academically rigorous. And I felt as though this is quite a good example of something called contempt culture. And the reason, and I should say actually, this wasn't the first and only piece of bad advice I received. I think maybe the second meetup I went to as a Haskell developer, I discussed with someone, I think it was quite a prominent member of the Haskell community, about my past experience, which has been in dynamically typed programming languages. I've worked with Clojure for a little bit before joining the Haskell community. And the first response to my entire experience was, oh, that language is awful. How can you work with dynamically typed languages? And they didn't use the word awful, it was a bit stronger than that. But essentially it was what I thought was a great example of contempt culture, which is described really, really well by Oren Shaw in a series of blog posts, and where she describes it as essentially showing contempt towards other tools, other systems, other operating systems, other languages, as a means of gaining social currency into the community that you want to be a part of. So for some people, that might be, describing different languages as crap or whatever. I mean, I don't know, see a show of hands, how many people have probably, I think we're all guilty at some point of saying, being a little bit judgmental, a little bit harsh about one thing or the other. And I think it's fine, we're all social beings. This is, it doesn't mean that that we're bad people, but I think we have to acknowledge that in the context of contempt culture, this is actively discouraging newcomers to the community. It's small comments like, don't do X because it's bad. Don't learn Y language because it's not as good as X language. And what this isn't is like a balanced sort of argument about the pros and cons and merits of any of these tools. It's that blanket statement, which I think is particularly discouraging to newcomers, because what it does is it kind of invalidates their own experience. If someone else has come from working with Java or C or something, I, for one, have a massive amount of respect for them, because my first role was in functional programming language. So I don't feel like I've had the experience, or some might say the pain of some of the features and the headbutt moments against other programming languages. Oh, that seems to have gone off. So oh, it's back. So these are really good examples of contempt culture, and all I would say is, as a beginner, if you experience, instances of contempt culture, if you hear sort of people coming along and trying to be completely dismissive of one thing or the other, just be aware that that's that single person's view and it's not representative of the whole community. And for practitioners who've been here a long time, just be very aware that those small kinds of comments can be extremely off-putting at a first glance. If that's your first experience, and you've got people being dismissive of the things that you've worked with, or the tools that you've used, or the languages that you've worked with in the past, that's projecting that idea of something being superior and something else being inferior onto the person. I should also mention here, actually, that Orenshaw discusses the fact that communities where there's a lot of contempt culture, which is I think rife in the programming community, disproportionately affects other marginalized groups, because they're typically more likely to be I suppose disproportionately affected by these small kinds of events, because of the amount of I suppose discrimination that they experience in society. They're less likely to be bothered to put up with that, and actually that's the kind of thing that, having seen one or two of those events, they just remove themselves from that space or that community altogether. So the last thing I should say on that is, after experiencing a couple of these instances, I kind of just decided to pull together a small study group. So I ended up looking at, there's a great course from the University of Pennsylvania on Haskell, and I pulled together a small study group because I kind of couldn't be bothered with the kind of what I saw as a bit of a culture of contempt in the Haskell community from my first couple of experiences, and I just thought, I just want to learn Haskell. So I got a few people together, some people that I worked with, and a couple of people that I went to university with, and we just studied Haskell together. And I think I would recommend for newcomers, if you're a little bit nervous about joining the community for these reasons, I think it's okay to have your own sort of small community to start off with. So once I had a solid grasp of what I felt was a solid grasp of kind of the Haskell syntax and some of the core concepts, I kind of wanted to, this was me leveling up. So this was me I spent about a month going through that cycle of learning the syntax, doing some small projects, and then a month pretty quickly ran out, unfortunately. So I then found myself at a desk surrounded by loads of PhDs, expected to write Haskell. So it's like, okay, this is fine. Yeah, I would say that I probably started the job with a level of maybe hopeless naivety. And I actually had a great induction. I'm joking about that. We went through, got my computer set up, had probably a week of pairing with my colleagues on different aspects of the system to familiarize myself. One of my first tasks as a professional Haskell developer was setting up, adding a couple of, so I mentioned before, we developed some tools for quantitative developers to get an idea of the overall state of their build system and tests and everything else. One of my first tasks was to develop, to extend, add a query and extend the API and surface some information about the longest running tests in our entire test suite, or the developer suite, and surface this in a nice dashboard. So the first thing I had to do was add a query. We're using a library called Esquelito, which was a really nice kind of typed SQL library. So I thought, okay, this is great. I'll see what other examples there are of functions and see if I can extend or reuse or do something similar to that. So this was one of this was a kind of contrived example of one of the queries that I was expected to have to write or extend. And I thought, okay, well, I know how to do this. I can grab the test outcomes that have a value that are successful, and I can filter those down to see the longest, or aggregate those to see the longest running successful tests. All fine and good. And I was like, oh, in the kind of about to go down a rabbit hole way that I do. What's this little, oh, it's not going. Oh no, what's this little operator here? I've seen this before, and I've seen it before in the context of like record access, and you all know what's coming next now, but I've seen it in the context of record access, but what I haven't seen it is in the context of accessing fields from entities in a database. So maybe there's a more general rule here, which is why this operator looks like this, and maybe there's something going on here. So let me look at the library version, which was the Esqueleto version, to access that field from an entity. And also let me look at the more common Lens version. And so on probably what was my first or second day as a professional Haskell developer, come up against this. And I'm sure I'm not the only person that was probably a little bit daunted at seeing the type annotations in the Lens library. Please raise your hand so I know I'm not the only one. This is so reassuring, thank you. For the video, everyone put up their hand. Almost everyone. So what I'm not here to do is shame libraries or talk about lines. The Lens library is absolutely fantastic. I would just say, let's not pretend that this is a beginner, newbie, accessible version of documentation in a library. So that's kind of the next thing that I want to talk about, is some of the documentation in the Haskell ecosystem is very type-driven, I think, which is great because it was a strongly statically typed language. We should totally be able to understand types. But I wonder whether there could be something more that we could do to possibly improve this. I think one of the downsides as well of having, I suppose, what we would describe as like hard documentation, which I'll go into in a second, is that it makes it very difficult for practitioners to decide between libraries. If I only have documentation that consists of type annotations and I suppose, description of the inputs and outputs of my function, I don't really have a very good way of, I suppose, qualitatively comparing two libraries that try to achieve the same thing. Which one is the best for my purposes? So I wanted to talk a little bit about, I'm not the only person that thinks this. This is from the State of Haskell survey last year. The second biggest gripe out of all of the options offered to a load of developers was in fact the documentation. So I thought it was super important to mention this. And also one of the downsides of, I've mentioned that. So I wanted to talk about soft and hard documentation, which a guy called Luis Pedro Coelho mentioned in a blog post. I think Haskell as a community and as an ecosystem, we're great at this stuff. Basically, anything that we can, I suppose, automate or that's already part of the systems or the code that we're writing, fantastic. I can retype. I don't have to add anything extra in order to, I suppose, display some meaning in my documentation if I only show you the type signatures and some function descriptions. And that's the kind of thing that can be, I suppose, generated by the likes of HaskellX or whatever, which is fine. There is nothing wrong with this. I suppose what I would describe as like hard documentation. I think one of the things that I've definitely noticed is lacking in a lot of our libraries and packages is the softer documentation. So problem definitions, and I think again this will allow people to decide, make I suppose informed decisions about which libraries to go to work with, and quickly. If you're doing this in a production code base, I don't want to have to spend 2 days evaluating which library to use by spending maybe a day on each or whatever and trying to evaluate it through use. It would be super useful if you just described that for me and just told me exactly what problem it is you're trying to solve and how you solve it better than other things out there. Installation and setup, I know is super simple, right? It's like whatever build tool you use, just include a couple of lines in there. And I think it was, again, super useful, something that's trivial for us as developers maybe to add, but super useful for newcomers who might be trying to build your examples for the first time and having compilation errors or something. More than one example. I've seen a load of libraries with a single example, not many with with, I suppose, more than one or more in depth. Maybe there's something that's a couple of lines, an example that's a couple of lines long for beginners, something that's a little bit more involved for intermediate and advanced users. So that would be great. Again, this is all soft documentation, so this is all kind of prosy terminology explanation. I think would be super useful, especially where your library or your package uses specific data types or specific terms or things that aren't common to, I suppose, the core Haskell naming and terminology. Contribution guidelines, FAQs and tutorials, etc. I'll show you a couple of good examples of documentation in a sec. Let's try that again. Anything happening? Let's try that. Fantastic. So, if I can be in love with documentation or a tutorial, I would be in love with the Turtle documentation or tutorial, written by Gabriel Gonzalez, and it has pretty much all of the things that I described in the kind of softer documentation and also hard documentation. It describes why it's useful, what it does, how to install it. This is a full, I mean, this is like absolute best case scenario, right? I'm not expecting people to go out and write tutorials for everything they write, but if your library, if your package is heavily used, this would be super useful to encourage others to use your library, to encourage others to extend and help maintain your library. And I used the Lens example before, so I'll use a comparable one that's in the Racket language. I don't know her real name, but her Twitter name is Lexi Lambda, and she wrote a blog post that was also a bit of a rant or an experience report on using Haskell, and she used this as a great sort of tutorial to compare to, and a good example of fantastic documentation for the same thing that I think the current Lens documentation, we can maybe compare the two and see that this is a lot more accessible to new Haskellers. So again, it's very easy for me to point to examples and say, this is fantastic. We should all, thank you. We should all improve our documentation, right? But it's a ton of work. And actually, what I don't want to do here is dismiss the load of hard work that already goes into developing and testing and maintaining libraries and large packages, especially when they're used by loads of other people. But as a community, why not have this as a community effort and encourage people to contribute documentation as newbies? That's almost the ideal scenario as a newcomer. There's the opportunity there to, when you hit your head up against difficult to understand documentation or things to use, why not make that an opportunity to allow newcomers to contribute? Which brings me to the next question, which is, what is stopping people from contributing? Again, this is a single answer from the State of Haskell survey around why people don't contribute. I think some of the main reasons were it's just unclear what the expectation is around contribution and whether they're allowed to contribute to libraries. There's nothing really stating that it's okay or that their contributions will be taken seriously. And so the one thing I'd just say to that is that I think as a community we can be much more explicit in our openness and willingness to encourage people to contribute to our packages. So on the contribution front, I did a quick and very scientific analysis of the top 10 downloaded packages on Hackage, and I've anonymized them at the top. So each column corresponds to one of the top 10 downloaded packages on Hackage, and on the left-hand side is the list of things that GitHub recommends as kind of great contribution guidance, with exception to the soft docs, which I added in. So we can see that everyone's got a description. Fantastic, we're doing well, and a README. A couple are missing the kind of softer documentation, so that whether that's tutorials or a few more examples. All but one have a license, which is interesting. Only 3 have contribution guidelines. Only 1 has PR templates or guidance around how to raise an issue for the library. None of which have a code of conduct, which is probably the topic of another talk. Of course, I'm not going to try and extract any conclusions from this, but 2.5 out of these 10, it's not particularly significant, 2.5 more issues are raised for those with contributing guidelines, excluding one of the massive outliers, which had like 5,000 contributions. Nearly 3 more PRs were raised for those who had contribution guidelines, and more than 3 times as many contributors. So this is just, if we can draw anything from this tiny sample, just like add some contribution guidelines. I mean, I think it's something that if you want people to contribute to your work, then let's explicitly encourage people to do so. Sorry? Are they ordered from most downloaded to least downloaded? No, they're ordered by how many boxes they tick off. I did think, I had that first of all, and then I was like, hang on a minute, this isn't anonymous at all. Took me a while. So I suppose the last thing I would say on that is just beware, I think one thing that we can learn from documentation is to be aware of that, I suppose, that gap in the Haskell pyramid that I showed you earlier. We're not always, I think sometimes as we kind of ascend that pyramid of Haskell understanding, we can forget what it's like to learn that thing for the first time. So I think what's his name? Someone talks about the monad fallacy, monad tutorial fallacy, right? Because as soon as you've understood the concept of monads, you forget how difficult it was to learn in the first place, and because once you've developed that intuition, you're like, oh yeah, it's totally easy. It's like a burrito, right? So I think we can apply that in the context of documentation, and just as you're going through, remember what it was like to open up your library or look at your code for the first time. I have all of 5 minutes left, if that, 10 minutes, fantastic. So I'm going to skim through this last bit, which was going to be a mini rant on possibly tooling. And also, when I first wrote this talk abstract, I was like, by this point, I'm going to be an advanced Haskell developer, whatever an advanced Haskell developer is. I'm going to be 10x. I'm going to know everything there is to know about Haskell, which is very ambitious after the space of a year and a half. And I was going to talk to you about developing your skills as an advanced Haskell developer. That hasn't happened yet. I'm still waiting for that. For that point in time where I can consider myself even maybe an intermediate Haskell developer. But what I would like to do in this short space of time is point to a few resources that I'm really excited about in terms of developing yourself as an intermediate, from an intermediate to an advanced Haskell developer that I've seen. I can't do much more than list them at the moment, but I've also created a GitHub repo. These are some of the ones that I've seen most commonly mentioned on the likes of Reddit and Twitter and things like that. The joy of Haskell I'm super excited about, and the type classes stuff as well. Again, category theory for programmers is a fantastic resource if you're interested in learning category theory and more about the types that underpin and the mathematics that underpin the language that we work with regularly. So I'm super enthused about all of these fantastic resources. I do wonder whether there's a possible gap in the market for, I suppose, a canonical advanced Haskell resource, but again, I'm not there yet. So if maybe when downstairs, if anyone has any suggestions for more advanced resources, then I imagine you'd probably specialize as you get more advanced anyway. But if anyone has any suggestions, then that would be great. Also, I wondered if we could take something from the academic community in terms of mentorship. When people do masters, I suppose you have a mentor or a guide and someone to look after your help you progress through your project and keep track of you as you're developing your project. I wondered if we can extend that out to in the Haskell community, whose origins were that Haskell should be suitable for teaching, research, and applications. And I want to emphasize on the teaching aspect of it. I feel like the whole idea of Haskell is that it's a really sound basis to develop learning tools. It's an academically sort of grounded language with a really sound basis for teaching and going through in a kind of pedagogically sound way Haskell, more and more progressively advanced Haskell concepts. So why not open that up to, I suppose, mentorship as well? And so there's a side from that which is having advanced Haskell reading, but also I think mentorship is a great opportunity for that as well. And one thing that I've seen actually that's come as part of the Hacktoberfest that I'm really excited about is that there are certain companies that are offering Haskell mentorship for those who are maybe even at the beginning of their Haskell journey. I don't think they're specifying a range of experience, but I just think this is fantastic in terms of helping people who might be a little bit nervous about where to go from building a simple program between that and developing sort of a full-scale application or working in production. There seems to be a little bit less of a material, a wealth of resources for doing that. So to summarize, I would say that at the beginner level, just be aware of contempt culture and potentially putting off newcomers from the community with very small and very kind of half, not even considered comments. If you do want to discuss the pros and cons of languages or tools or anything else, do so, but just be aware that if you're not doing it in a balanced way, you're possibly invalidating people's experiences based on what they've worked with before or the things that they've used before. And just be aware of the advice that you give and whether or not it's actually coming from a place of experience or whether you're saying it because it makes you feel better about being in the in-group. I suppose leveling up, documenting as you go. Like if we can, it's difficult to empathize with people it's difficult to empathize with you from 6 months ago once you've already developed the intuition for a concept. So have others in the community and encourage others in the community to document as they go and equally document as you go so that we can overall improve the quality of our documentation and our ecosystem and actively encourage people to contribute. Otherwise, it seems like we just won't. And we improve on our code as we go. We try to clean up whenever we touch a particular part of the code base, we try and add more tests for it. We try and clean it up or make it more idiomatic based on what we've learned. Why not do the same with our ecosystem and with our documentation? And then moving faster, I suppose even scaling up even faster. I see mentorship as a great opportunity and something that I haven't seen a whole load of in the Haskell community, but I think could be super useful. And also intermediate to advanced resources. If people have suggestions for them that aren't academic papers as well, because maybe that's another facet that might be a little bit less accessible to people who aren't part of the academic community. So, yeah, I think overall, wherever we can, let's bring other people with us in the Haskell community and document as we go, help others as we come along, mentor others as we grow. And that's roughly it. I've put all the learning resources that I've come across that I think is a kind of opinionated list of learning resources, just because I've had a look at them and I think they're great, and I think they've come from kind of an aggregation of other meta resources. But again, this is open to pull requests, open to contribution, open to comments and issues and stuff if you have any other ideas. Thank you very much.
On, actually?
With regard to the contempt culture, what do you do when you're faced with a person who's coming into the community, and let's say they use language X, and you've given up hope that there is actually any benefit to language X over language Y? Like, how do you deal with that? You can't tell a problem. Well, there are pros.
Well, I think you can. I think you can discuss it in a balanced way, right? You can say, well, my experience of it has been this. I've been working with it for the last year and a half, and actually I struggled with this and this and this and this. And you can talk about it in a way that explicitly highlights from your experience the pros and the cons. In the same way that I could have come up and said, oh, the ecosystem is messed up, and then just walked off stage. I didn't. I was trying to come up with examples to illustrate the things that I've come across based on my experience and how my suggestions to improve them. And sometimes the suggestions for improvement is to use a different language. There's nothing wrong with that, and I don't think that's contemptuous. I suppose the main measure would be when you come out of the conversation. Has that person learned something? Have they understood the pros and cons or merits of a particular thing? Or have you come out feeling smug or better about yourself or better for being part of the in-group? I think that's probably a good measure.
Hello, thanks for a great talk. I want to just say one of the resources that I found really useful when I was first learning Haskell, which has kind of quite a good community feel to it, was the IRC channel on Freenode. I found that people there were really helpful and were happy to, dig into and look and review my code sometimes. So that was good. I also have a question. I just wanted to ask how you felt the development process was using Haskell in your first job. How has it changed? Was it more difficult? Was it easier to iterate?
Short answer, no. I think, and in terms of, that was the answer to the, is it easier to iterate? I was working with Clojure before. Again, it's a dynamically typed functional language, which I think, again, one of its merits and one of the applications that it's very well suited to is rapid iteration. So you have a REPL, you can, it's very, very easy to sort of experiment with progressively larger and larger snippets of code, and once you've got something working, it's almost the types, because it's dynamically typed, you don't have to think about, there's no design up front, you don't really have to think about what you want your overall type, you don't have to design your types in advance with that. So I found actually one of my biggest frustrations with working with Haskell definitely in the first couple of months, was that I couldn't just, I found it a lot more difficult to rapidly iterate on progressively larger and larger chunks of code, or develop my ideas as I was going along. I kind of had to have a rough idea of what I wanted my finished, at least at a function level, my finished thing to look like, so that I could describe it in terms of its types, so that I could then build out the functionality. Does that answer your question? What I would add to that, actually, because obviously I'm still working with Haskell and it's fantastic, is that then on the flip side of that, the thing that Haskell's great for is, I think once you've established your, whatever it is, your minimum viable product, or once you've proven an idea in something that's not typed, then get it robust, right? You want to put some, like, solidify that idea and encode that in your types. I think it's great.
So, so we have dynamic aspects in Haskell, like deferred type errors, all these underscore things. Is that something that you would then like to introduce to beginners earlier? So, or people coming from a dynamic language, you should say, just enable deferred type errors, then it's just like your Lisp environment. Is that something you would recommend?
That's a good question, but no, absolutely not. I think this has only come from my experience, right? Because my experience has been in dynamically typed languages. It's kind of similar to what I was saying at the beginning, in that I think part of the reason that Haskell is considered to be hard is because you have to unlearn to a certain extent your habits from whatever background you come from. And I would say to absolute programming newbies, Haskell's a great first language to start off with in its current form, because I think it teaches you how to construct program. I don't think there is necessarily anything bad with sort of thinking about your types up front, or thinking of your overall solution up front. I think it encourages great design and kind of architectural skill development. I just think, coming from any other language, you have to sort of unlearn your own patterns of behavior, and that was one of the things that I found quite frustrating to start off with.
Okay, I think we have to stop here. We can continue the discussion in the coffee break. Let's thank Abby again.
Thank you very much.